So in the last video, things didn't work out so well. The knob that I added to adjust the common mode rejection of my amplifier didn't work, and I found a couple of new sources of noise to deal with. But also, between filming and editing and uploading the video, I found another YouTube channel called BPM Biosignals, which has some really nice videos, one of which talks about common artifacts in ECG, which goes over exactly the same sorts of artifacts and noise sources that I had in the last video. I'll put a link to the video over here in an annotation so you can go check it out. I'll also put another link down in the description just in case you don't get annotations. So definitely go check that out. It's super informative and also kind of relaxing. That lady's like the Bob Ross of biosensing. Let's start by addressing the 60 Hz problem, which is caused by an imbalance in the two signal paths, giving us bad common mode rejection. In this case, it looks like it's being caused by the same mechanism that was giving me a bad DC offset when I was using the LM324. So when I was using the LM324, I was having current flow out of the inputs of the amplifier and through the resistance of my body, which was causing a voltage drop. And because that voltage drop was different at the two electrodes, that caused a differential DC voltage at the input of the amplifier, which turned into a DC offset at the output. So it looks like this time it's the same thing. The imbalance in resistance between the two electrodes is still messing up my stuff, but in this case it's not from the bias currents from the op-amp, but from the currents caused by the ECG voltage. So in the last video I'd made the assumption, without telling you, or I guess without realizing it, that there would be no current flowing into or out of the inputs of the amplifier because the amplifier had such a high input resistance. And no current means no voltage drop over these resistors, so no matter how imbalanced these resistors were, the voltage would still be balanced. But that appears to not be the case here. In the BPM Biosignals video, Vasso's new wet electrodes worked a lot better than the old dry electrodes, and that's presumably because the wet electrodes have a much lower resistance, and a current over a lower resistance gives you a lower voltage drop, which means less voltage imbalance between the two channels. So it looks like my side experiment with the solder-covered electrodes might come in handy now, because this means I can use the conductive jelly in order to lower the resistance of the electrodes and hopefully get a better common mode rejection that way. And another source of noise came from cable movement. Vasso didn't explain the mechanism behind this, so I don't know exactly how this noise is generated, but for me, the noise was generated not just when the cable moved, but whenever the cable rubbed up against me. So keep in mind this is just speculation and I'm probably wrong, but I think the noise might be coming from static electricity. So my thought is that as the cable rubs up against my body, the insulation on the cables will rub off some of the electrons, giving it a negative charge and my body a slight positive charge. And this would cause a voltage that the amplifier could pick up and read. You might normally think of static electricity showing up as a series of pops, where the electrons build up and build up until the voltage gets too high and breaks down whatever non-conducting barrier is there and discharges. In this case, it wasn't a series of pops, and I think that's because the cable and electrode also form a return path for the electrons, so that as soon as they build up, they can discharge without building up to the point where it breaks down and pops. But the voltage is still there long enough for the amplifier to read. I think I can test this by just rubbing one of the cables up against me and then looking at the DC offset correction. If I'm right about this and the static electricity is building up a voltage on one of the cables, but not the other, then I should see a DC offset at the output. If I'm right about this and this noise is coming from static electricity, then unfortunately there's not much I can do about it, except maybe tape the cables down like Vasso suggested in her video, or try some different insulation materials on the cable. And the last noise source is electrical signals from my muscles, or I guess the muscles other than my heart, polluting my ECG signal. And I don't think there's all that much I can do about this either. I did notice that Vasso's electrode placement was completely different than my electrode placement, and she presumably knows a lot more about ECG than I do, so I'm going to switch to her electrode placement, and hopefully that'll be better at picking up the heartbeat signal and less vulnerable to picking up EMG noise. And the last thing to do is to swap out these 100 kilo ohm resistors in the back end with 10 kilo ohm resistors. And that should give my 10 kilo ohm variable resistor a lot more pulling power when I try to change the ratio of these two resistors. And that should give me a lot wider range when I'm adjusting the gain of the signal path, which means that the gain for the best balance should be somewhere on the dial this time instead of off the dial. So that's it for this video. In the next video I'll make all those improvements and see what happens.